Hello guys, today I'm going to explain you how can we solve this problem from Leetcode's June challenge. This problem name is surrounded regions, and what we need to do is we are given basically a 2D array which contains X and O, and we need to capture all the regions which are surrounded by X. So basically capturing means we need to flip all the O's into X which are surrounded by X, and there are certain rules as well. Basically any O that is not on the border and is not connected to an O which is on the border will be flipped. So basically any O which are and two cells are connected if they share some adjacent like edge. So basically here, as you can see, these three are actually flipped, but not this one because this itself is on boundary. And if, let's say, imagine if there was this particular cell was 0 also, then none of these 0 would be flipped because all of them are somehow connected to this O on the boundary. I am saying this 0, but I mean O. So let me explain you quickly through some other examples, and then we'll proceed towards our algorithm. So guys, let me take this example where this grid of cells are represented such that the black ones are X and the empty ones are O. So what we need to do, we need to mark all these cells. We need to also flip the ones which are empty to be black, and we need to take care of a certain case that if there are certain cells which are on the boundary or on the border of this grid, they shouldn't be marked, and also the ones which are marked which are connected to some of the cells which are on the border. So for example, this and yeah, these two cells are somehow connected to these cells on the border, so these should also be not marked. So in fact this should be left as it is, and also this one should be left as it is. All right, so let me explain you what we can do here. So what are we supposed to do is to basically somehow mark these cells which are connected to one of the cells which are on the boundary and they are empty. So one can simply do a DFS starting from all the empty cells on the boundary, and then just find all the connected components or all the connected cells and keep on marking them. So what we can do, we can start a DFS from this cell, and then we can mark these two cells, and similarly we can start a DFS from here and it will mark these two cells. Then we'll start a DFS from here, and then it will sorry, not here because this is not a boundary cell, so we are here now. It will mark these two cells, and then what we are going to do, we find this one as the next boundary cell, and then this is going to mark all these cells, and then there are no more cells left which are on the boundary and they are empty. So what we are going to do, then we are going to start our traversal from this grid within the boundary. So basically this particular grid, traverse over all these cells and mark all of them as empty. So basically what we need to do now is we need to flip all of these to colored one. So I'm just saying that coloring it with red so that we can identify or distinguish between these unmarked and the marked ones. So these need to be marked. All right, so what if let's say this cell was not there, this particular cell was not there. So in that case what would happen is, once we start a DFS from here, it will mark all of them because they all are connected to this particular cell, and sorry, yeah, they all are connected to this particular cell. So in that case our matrix would look like exactly same what it was in the beginning, because they all are marked and there is no cell left which is going to be flipped. And also to keep in mind, when we are doing a DFS from one cell, we are only going to up, right, left and bottom, so we are not going diagonal. So in case when we were here somewhere, so we didn't directly come from this cell and then here, we just stopped from here to here, and then we once we did a DFS from this cell, and when we started from this DFS, doing DFS from here, then only we marked this one. Otherwise this would also go and continue marking this to these all these cells as well. So we are only considering the four cells which are adjacent to the current cell instead of the diagonal ones. So yeah, I hope it's very clear. So let me just quickly walk you through my code so that I can explain you better. So the code is a bit lengthy, but it is pretty straightforward and clear. So what I've done is I've declared a bunch of variables. First one is to just replicate our given grid so that I don't have to pass it into my DFS every time. I am also keeping a widgeted table where I would mark all these cells whether they are already visited or not. As I said, when I am going to mark these two cells, I wouldn't, and yeah, basically I just want to keep track of all the cells which are not connected to the boundary cells which are empty. So here I'm keeping that this table for that purpose. Then I've just declared this array to iterate, or I go on to the left, top, right and bottom, and I've declared one function which will tell me whether this current cell is a safe cell to travel or not. That means if it is not passing the boundaries. So this is the case. These are two cases where I'm explicitly checking whether the current cell is not out of the boundary, and then whether this current cell is already visited or not, and if this cell has a 0 or not. So in these all these cases, if any of them is correct, then it will return false, otherwise we will return true. Then what I'm doing here is basically I'm checking these two edge cases, that if my matrix is empty, then I don't need to do anything, return from there itself, and otherwise I will yeah, set all the cells initially marked as false. Then here I'm checking for the boundaries. Like as I said, I'll do a DFS from the cells which are empty and those who are on the boundary. So here I'm doing for the first column, then last column, then first column, and then last column, that if any of these cells on these boundary are not visited, and if they are 0, that means empty cell, then I'll start a DFS from that particular cell. And what I'm doing in the DFS is basically, yeah, as I said, I'll go up, down, left, right, and just keep on marking all those cells which are connected to it. So I'm marking this by doing visited of that particular cell as true. So once I'm done marking all the cells which are connected to the empty cells on the boundaries, what I'm doing is now I'm going inside the boundary and traversing over all my matrix, all the cells in the matrix, as you can see, starting from 1 to n-1, like, yeah, from here till here, and exactly from here till here. So I'm not touching boundary at all, I'm just covering this area. And then what you can see is, once I find any visited cell, any not visited cell, and if that cell is marked as O, then I'm marking it as flipping it, or flipping it with X. So yeah, that's it. This was supposed to be done in place, and that's what we've done. And yeah, as you can see, it's already accepted. So yeah, thanks for watching this video, guys. If there is anything that you want to discuss, or if there is any feedback for me or any comments, please let me know that in the comment section below. And if you like my work, please do subscribe to my channel. There are a bunch of other videos which you might find helpful for you. Thank you for watching this.